How to make a completely custom dash with your own switches, turn signals, lights, brakes, windshield wipers, hazards, horn, all from scratch. Radiator blew up on the way to the Good Guys Car Show in July of 25. My son and I were on the way to that show. Stranded us. We didn't make it with the truck to the show. I ordered a new Champion radiator with twin electric fans, and this started a project that ultimately ended up in a complete and total rewire of the truck. I didn't know it at the time. I thought I was just going to install this nice new radiator with all of these fans. 2 fans instead of 1. Huge upgrade. It ended up leading to a huge troubleshooting fiasco. My brake lights stopped working. My turn signals stopped working. So it ended up becoming a project where all of this was going to get addressed at once. So here we are unboxing the fan and the radiator. This is a nice unit. It's much thicker than the other one that I used to have in there. This is me test fitting it. I wanted to make sure that the upper and lower radiator hoses would mate with the same locations, which they did. I also needed to check and see if the existing electronics would be acceptable to use. This is me working with my son, showing him where the thermostat switch is. This thermostat switch ends up switching a relay, and I'm using the wiring that was already in place from the old relay to wire this in. This shroud mounts both the fans, so drill some holes, put some bolts through. So I used locking washers to install these. I showed my son how to cut and measure and drill for holes, and he helped me crank them down and get them installed there. I was trying to be very careful with the radiator. I didn't want to dent it or drop it. But in fact, I just used the zip ties that were in the kit, pulled them through the radiator fins, and then mounted the shroud that way and dropped it in place. This was the existing upper plate that was in use with the old radiator. I had to cut that down and trim it to make it fit the new radiator, but it really wasn't too bad. Just with a little bit of cut and trim there, it worked. And so there's the new radiator in place, and now it's just a matter of hooking up the hoses and the relay. Now the relay was a little bit tricky. I had to modify this upper radiator hose. You can see there it didn't quite fit right, so I had to find one that had actually a wider outlet than an inlet, but that ended up working. The instructions for this weren't bad. It's a nice relay. It's got a waterproof harness on it, so you don't have to wire directly to the 4-pin relay or use like a standard 4-pin relay connector. You can use this nice waterproof one. This gray goes to the temperature sender, so that's that guy right there. The red goes to these, so we got to wire these in. Orange goes to the 12-volt ignition source, which I think I'll be able to find from the old one. Fuse, yellow wire goes to the positive terminal on the battery with this. And this is a nice little inline fuse holder.
I feel like one of those robots from Star Wars that are like, beep, 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 boop, beep, boop,
Yeah.
fixing.
Now I know this looks real sloppy, but we will smush it all together because we're doing 3 wires at once. These are the fan pigtails. I'm gonna mount them here. Keep them out of the way of the fans. This is their common ground. I'm gonna put it right here on the firewall where this relay mounts. This is supposed to be to a 12-volt switch source. I think this is one. This looks like is what it was wired to before. This goes to the battery. I need to put a 30 amp fuse in there. This goes to the temperature switch. That goes to the fan itself. So I was trying to trace the wiring harness back. You could see that this wiring harness has been modified. I've done a little bit to it, but somebody did a lot to it. These are the stock colors, and you can see I'm tracing the front wiring harness through the engine bay. That goes all the way back to the fuse block. And then the back wiring harness also comes out of this and goes down underneath the firewall and runs towards the back of the truck and then splits to cover both the left and rear tail lights as well as the license plate running light. The running lights in this truck have never worked, and just looking at this, it was such a mess. I thought maybe I should try to address all of this at once. But I wanted to make sure that the lights themselves were not the problem, and so I decided to look at maybe replacing the light switch, but I needed to make sure that the lights themselves were working first.
Alright, so this one with the two wires is white and black. I'm assuming the black is ground, so I'm going to go to the body of the connector. Ground is on the body, and then the end of it is the connector that pushes into the light bulb connector. And you can see what that is the reverse light. So that works. So body of the connector, this pin is, I think, looks like pretty bright, so it's probably brake light. And then the other one looks like running light. Probably running light, yeah. So brake light is probably red, and then the white is running light.
All right, so I did all that pin out and determined that the taillights did work. And here I am with the back in the truck and nothing. No brake lights, no turn signals now at all, nothing. So digging deeper into the dash, trying to understand, maybe it's the turn signal switch. So I bought a new turn signal switch. But the challenge with this is there is a wire harness on the switch here, and it's kept in place with that hazard switch, but this harness goes all the way through the steering column, and the connector on the end of it is actually quite large. The only way to get it out is to depin the connector. The way that you remove it is use a pick or a very small flathead screwdriver, and if you push it in there, there's a little tab that prevents the pin from being pulled out. So you push that tab down and then you can pull it out. So here I am doing it on the cut connector so you can see. So that one's successfully removed. So instead of trying to fish it through the other way, here's what I ended up doing. I taped the end and then tried to stuff it down the inside of the steering column. And if you run into anything, which you will, there's all kinds of stuff in the steering column. It's meant to be a tilt column, but the gear selector's in there. You can get it, and I was getting a bit frustrated, but I kept pushing it through. So there we are. We've got it mostly through, and I can almost taste it. Almost get that thing mounted. I got the steering wheel all put back together, and brake lights still don't work. And watch this. I disconnected the speedo cable, and there's been this thing in the engine bay that has been sticking out for a long time. I'm like, what is that? Oh, that's why the speedometer didn't work. All right, so now I'd pretty much given up on trying to troubleshoot the existing wiring in the car and all the switches, and I started exploring the idea of putting in my own standalone wiring harness. And I was using PowerPoint to trace out wiring diagrams and potential fuse block ideas. I wasn't fully committed on doing this, but I thought, okay, I'll invest a little bit of time and just see if I can make something that looks decent. So this is the general mock-up, and these are the parts I'm using. So, and I bought, you see there, a new plastic OEM piece that I was going to use to basically hack up and fit this in there. This old one has some broken tabs on it, so it wouldn't be ideal. But the idea is to use toggle switches for turn signals and lights. And then you can see a couple other switches here are kind of nice. There's a push button switch for the horn, and there's another push button switch for the hazards there that's laying on the aluminum there. I'm picking it up to show too. And there's also a tack and a fuel gauge. Since I already have my other 3 gauges, there's the windshield wiper and then the USB port, which is always handy if you want to charge your phone while you're navigating or something like that. So 3 separate plates. They all fit reasonably well. It's just that gap in the middle ended up being a problem. So eventually I consolidated them into one single plate. So you can see here that this is a single plate that I'm looking at using. Cut it out of a new piece of aluminum stock with a nibbler, and then back over to the bandsaw, shaped it a little bit. So now I'm looking into making a relay board. So I bought a bunch of 4-pin relays, and I bought a standalone fuse block that you could use for like a boat. Look on Amazon for a marine fuse block or marine panel. And I got a bunch of these terminal blocks. I was trying to make this as symmetrical and laid out as cleanly as possible. I wanted to label each and every relay, and I knew I would have open circuits, and I just wanted to have that for expandability. A key part here is these 2 flashers up in the upper right hand corner that I'm pointing at. You need specific flashers for LEDs, and more on that later. That ends up being a very critical part of this entire build here. This vertical pin on the bottom is the 30, and that in the wiring harness is blue. The top pin is 87, and that is red on the wiring harness. The 86 pin is white, and the 85 pin, which is ground, is black. Your relay harness might be different. This is a common type of relay. It's 4-pin. This is a 40 amp relay. I found some Bosch ones that seemed very high quality. I honestly don't know what this brand is. I got it off Amazon. All of the circuits will be fused. The blue wire on the relays will go to the fuses, and then the white wires coming off the relays will be hanging off the relay board, and they go to the switches that are up on the panel. And then the red wire is what I would call the load wire, or sort of the execution wire. The red wire is what goes to the load. It powers a light, it powers a windshield wiper, it powers whatever. So the idea was to make all the reds come out to the end of the board here, so that I just run the leads from the loads to these terminal blocks and connect them directly, and the relays are doing all the work. And then I have a bunch of white wire leads that would come out of the relay and go up towards the gauge cluster where all my switches are. And so I basically have white coming on one side and red going out the other side, and it's all organized and it's all labeled. And then I would put labels on this board so that if you just looked at it, you could see relay 12 goes to circuit 12, which goes to lights, for example. And I wanted to keep that as tidy as possible. So you can see what I drew out in PowerPoint is now coming to life on the relay board itself, and just trying to keep it all clean. Also planning for the fact that all the wires coming into this are going to have spade terminals, and they're going to overlap one another, and I'm trying to keep it from becoming just a big spider web and a huge mess. That's one of the problems with wiring any vehicle, or even troubleshooting wiring in a vehicle, is it's hard to get to. First of all, you're on your back, usually in the footwell, looking at the fuse panel underneath the steering wheel, which is, I understand why they put it there, but it's a stupid place for it to be if you're trying to do any kind of maintenance or troubleshooting. and none of the circuits are clearly labeled. You're usually trying to read off some diagram in a maintenance manual or something, and you just can't see what goes where, and it's really difficult to even be able to figure out which fuse to pull. Ground is labeled on both ends. I have 12, 10, and 8 grounds connected to the fuse block. The 12, 10, and 8 correspond to the fuse positions, so all of them will be labeled like that. Since these are short pigtails, I'm going to have to extend everything that's going over here, so the white and red wires will all need to be extended. The blue wires will all go to the fuse terminals, so I will connect each of those as we go, but I'm doing the grounds first. I got this generic label maker from Amazon. Sup Van, you ever heard of that brand? Me neither. These are all extended. I guess I'll call these the trigger wires. These are all extended, soldered and heat shrunk. I'm going to do the same with these. The trigger wires on this side will go here. So you can see it's pretty tedious work. Each wire needed to be extended. That means soldering, heat shrinking every single wire, getting them all routed over to the bus bars, or terminal blocks. I keep calling them bus bars. Terminal blocks. Terminal blocks. And again, I'm trying to keep the white wires separate from the red wires. The red wires are the loads, the white wires are the switches. So switch leads come into one side of the terminal block and the other side goes to the relay. And then out of the relay comes the red wire for the load. I got a lot of instruction from this channel right here. This is Wiring Rescue. This guy has some great videos. They're a couple years old. He's so helpful, very instructive. He always wires it up on this pegboard and shows how relays work, how toggle switches work, different ways to wire up your car, and it's good stuff. I got a lot of help from him, so please go check out that channel. We are not affiliated or sponsored. I just really appreciate him. You should go check it out if you're watching this video and you're looking to wire something. So I had to swap out here. So relay 2 went to fuse position 2. So I took the blue wire off of fuse position 2 and I put it onto the positive lead on the flasher, and then I ran the load lead from the flasher back to 2. So what that means, power comes in from the fuse block, goes through the fuse, goes to this new baby blue wire here that's supposed to match my blue wire, but I couldn't match him. Comes through there, through the flasher. This creates intermittency, comes out into the relay. So the relay is intermittently getting switched on and off from the flasher. This is my trigger lead. This is my load lead. Okay. So it's getting to work on the dash panel and drilling the holes, trying to make the locations in obvious places so that they're ergonomic. There's the USB port. You can see these toggle switches for the turn signals, and then a toggle switch for parking and headlights. There's the horn, wiper, and hazard switch. That tack will end up being centered. To make the hole for the tack, I used a hole saw. There's better ways to do this. You can get like a fly cutter, which I thought I had one, but I couldn't find it. So I tried this, and you can see I'm really struggling with it, and it's making kind of a mess. But I actually used a hole saw that was about an 1/8 inch smaller than the hole I needed, and then I cleaned it up with this die grinder so that I could have a tight fit. And then I used a smaller hole saw for the fuel gauge, which worked a lot better because it didn't have so much torque on the whole plate. And clean it up with a sander around the edges again. And here's just a test fit. Obviously I'm going to clean all this up and sand it out, get a uniform grain going on, and get rid of all those permanent marker. I drilled all of the plate mounting holes. I carefully lined it up on top of this plastic dash bezel and drilled holes through it. So see here that there's a hole
all the way through. So it goes through the aluminum and the plastic. That will bolt this through here. The next issue is to cut the plastic out so that I can actually put my gauges in. I just don't want to compromise the structure of this thing too much. It's fine. I'm not super disappointed or anything. As long as it works, you know, that's really all I care about. Oh yeah, that's a sloppy mess. Looks terrible.
Finally, I'm test fitting everything here. Put the gauges in, I'm putting all the toggle switches and dash lights in, and here's the first time I've seen it mocked up. And the first time you're seeing it mocked up. So here I am, I'm cleaning it up and like trimming away a little bit of plastic at a time. Eventually I'll cut more of it out, but the next problem I had was I was going to put riv nuts in here, and the threaded piece for the riv nut tool was not long enough, so I had to make one. So here I am making it out of threaded rod, and the base has the hole in it, and then the upper part needs to be threaded. So I'm cleaning it up in the drill press, and then eventually I put it in a vise and thread the other end. And now I'll have a threaded piece for the riv nut tool that's long enough that I can push it all the way through the aluminum and the plastic and get that fastened to the plastic OEM dash bezel. And here's the riv nut. So I'm testing it on the new piece that I just made. You can see how it's longer than the old one. Inserting that into the riv nut tool, making sure that I'm allowing enough thread to get enough grab on the riv nut so that I can compress it. This riv nut will compress on the back side of the plastic, and what I'm trying to do is do this so that it doesn't crack. This is the new bezel that I'm doing this in, and you can see there it is, it compressed on the back, and now it's fixed in place and I have something to thread into. So I'm going to test fit the whole aluminum panel to this now, and you can see now it installs and comes out as one single piece, and that's what I wanted. So I can install the bezel and then install the dash plate. So I now have put in a positive terminal block. I can run 12 volts to that. It can be switched or unswitched, and then I can run everything off of that terminal block. And then here's a negative terminal block that I can ground everything to, so I can self-contain and consolidate all the wires behind the dash just to this plate, and it can be self-installed in and out. I'm going through final test fitment to make sure that there's no interference once all the bolts are threaded through into those nutserts, and it's working and it's looking pretty good.
So this is a red power block, meaning positive, 12 volt positive. This guy will go to a switched source that I already have in the truck. So I'm trying to label everything as I go. This will also make it easier for anybody that comes after me to be able to decipher what the heck this mess is. And then I'll have all these leads coming off. I'll have this ignition wire lead coming off. I can put all that into a single wiring harness that'll come off the back of the cluster. And hopefully I could put all that into maybe a connector. All right, I have a single wiring loom. All the wires coming out, all labeled. All right, so turn it on. A couple things I noticed right away. As soon as I hook up power to this light is always on, which means if I hook that up to constant 12 volt, it's gonna stay on, like even when the truck's off. So that's not gonna work. I'm gonna have to fix that.
all this is going just to a headlight as a test load, and it's going to the amber halo. So I'm going to switch this to L. Now this would power my windshield wipers, but we'll see if the light works. Yep. So L works. Here's headlight. Yeah. Cool. Just that alone is like a breakthrough. I mean, so now I'm going to try a blinker. Okay, so I should see something. Passenger turn. Oh my God! Look at that. Oh my God! It fucking works. Yeah. Oh man. It works. It freaking works. Oh my God. Okay, so I switched the terminals here. So yeah, when it goes to the left, that is on, and when it goes to the right, that is on. But I don't want the headlights coming on when I just want the parking lights on. But I do want the parking lights on when I want the headlights on. And now I've got the white halo on. I've got it connected to the L terminal on the wiper. So when this goes on, it should go through the flasher, and it should flash the white halo. Yeah. That's funny. All right, so headlight. It's going through the flasher switch, remember that. So ignore the fact that it's flashing. But look how much it draws. 1.2 amps. So even with all the lights on this dash, plus that, it's very low current. All right, so this might be scary. So I'm gonna flip the headlight on and the horn should honk. Holy shit. Wow, okay. That was loud. Also, not the tone I was looking for. Going through relay number 1, which goes through this flasher. I've switched the fuse to slot number 1. The load is in slot number 1, and the switch is in slot number 1. And the switch is going to the hazard line right here. So we're going to hit the hazard button. Let's see what happens. Ready, go. Nice. Okay, horn switch connected to circuit number 1 through relay number 1 and this flasher. Circuit number 1. Horn is connected. Positive and ground. Are we ready? This is no longer lit up all the time. This is now wired properly so that it only lights up when I press the button. When I press the button, the horn should honk. Are you ready? 3, 2, 1. Oh, wow, okay. Okay, I just spent a ton of time on this because I clipped those pigtails off. And one of them has 2 connectors on it, and this one has 1. And I connect everything up, and I'm thinking, okay, these blacks are the ground wires, right? No, they're not. I had to cut this thing apart and do an autopsy, only to find that the white wire is the ground. The white wire is the ground in this case, because, you know, that makes sense. All right, with that all sorted, I created this new pigtail. Instead of 3 separate wires on the back of this, now it's 1. Okay, I'm gonna switch these up to something that hopefully makes a little bit more sense, at least to me. 2 blacks are ground. The white is the reverse light. The red will be the brake light. The yellow will be the turn light, and the orange will be the run light. All right, these headlights are pretty faded, but I'll figure out a way to polish them. I took these pigtails off, those adapters, and extended them and then pinned them out and labeled them. Turn, high, low, and ground, and running lights on these. So it'll be a white halo running light, it'll be a amber turn signal, it'll be 3 of these are lit for low, and all 4 are lit for high. I'm going to do right turn signal. Nice. Now I'm going to do left turn signal. Okay. Now I'm going to do parking lights. Let's see, the halos are on. Now I'm going to do headlights. Both of those should be on. For some reason, only the right one's turning on. I don't know why. I'm trying to figure out what to do with the hazards. Now you can hear the switch, the relay working. You can hear it working for the horn too. But But if I run the hazard trigger wire, if I run the hazard load wire over here and I try to hook it to the same thing as the turn signals, for example, the orange halos, then they're just both on all the time, even when I try to do a blinker. When the headlights are on, I have taillights too. It doesn't quite accomplish what I wanted because I also wanted to be able to turn on, when I turn on the halos, now I have nothing on the taillights. I kind of wanted running lights when the halos are on. But this gets me down the road. I didn't have running taillights before, so this works. Okay, cool. Check this out. Blinker. Halo and rear. So that's the other side. Yeah, that's awesome. Okay, so I wired that into the switch, and let me show you what's happening. I turn on one blinker, and this is what I get. No, that's not what we wanted. Yep, that's not what we wanted at all. And when I do it, this turns on. If I click it, it doesn't make any difference. Dang it. All right, I've been stuck. I put a terminal block together here to just consolidate the wires. So all the running lights go into one block, all of the brakes go into that block. Driver side turn goes into one, passenger side turn goes into another, headlights goes into another. And I also have the brake light switch now wired up, okay? So this is like, if I turn on my brakes, that works. I've got headlights and halos and parking lights all running when I've got the headlight switch turned on, which is great. And the brakes work. Now, if I turn on the blinker, something's weird. I got one, but this guy is not blinking in the back. Okay, it's been a very frustrating couple weeks trying to troubleshoot this mess I've created. As you can see, I've removed the entire relay board. I've decided to go back to basics. There is a video from Wiring Rescue where he shows how to build a circuit using this switch. This is the American Auto Wire 500-148. I bought this a while back with the intent of using it, and then realized as I was putting all this together that maybe it wouldn't work with the relay board that I was designing, because in that circuit that he builds out on his video, and I need to remember to put this link in here, but look it up. It's called Wiring Rescue. It's a great channel. But anyway, he wires this whole circuit without relays. It's just a simple circuit like you would see in most older vehicles, which is a fuse block with switches and loads, and your main protection are the fuses, and so you're not doing anything with relays. And so when I tried to adapt his design to a circuit with relays, I started getting really confused on how this switch would work. And the reason is because this switch does something unique, which I believe addresses the issue that I've been having. You can see that you put a flasher input in here and you put the brake switch input in here. But then all of the individual lights at every corner of the car, each light is individually controlled. So you have a right-hand rear stop and turn at that pin, and you have a left-hand rear stop and turn at that pin, and you have a left-hand front turn at that pin only, and you have a right-hand front turn at that pin only. So they are all isolated. All this switch is a turn signal switch. So it looks like a double throw switch, left, right, but I think what it's doing is isolating the brake light circuit so that I can actually use my brake lights as intended without having some circuit interference that I still don't fully understand I was having in my relay board. So I'm hoping this will fix it. I don't know if it will. All right,
So I installed the American Autowire 500 148 switch in place of the turn signal switch. So the brake switch goes into that American Autowire switch, as does this flasher. So this would be, I'm driving down the road, I have not hit the brakes. Turn on my turn signals. That's great. And then watch when I turn on my brakes. That's awesome, right? That's how it's supposed to look. This brake light is on, the other one's blinking, brake goes off, normal blinking, brake goes on. That's exactly what I want, okay? Same for the other side. Brake goes on, the other rear brake is on while the blinker's on. That's exactly what I want. That's perfect. That solves the problem that I had before. I actually have functioning blinkers with brake lights, the way that they're supposed to work. Now, I'm gonna try to turn on my parking lights, okay? So, driving down the road, parking lights are great. I've got tail running lights, I've got my halos on, brakes work, that's beautiful. Now I'm gonna turn on my headlights. That's great. Driving down the road, headlights are on, I got running lights on my tail lights, brakes work. That's great. So far so good, right? Now let's turn on blinkers. Oops. No blinking. Okay, I think I solved it. All right, so right now I have a new relay. This is actually the 4th or 5th relay I've tried. These relays did not work because they're only 2-pin and they have no ground. And I was using these the whole time. Okay, so these were probably my problem all along, but it took me a long time to figure that out. I just figured it out in the last couple days. So don't use these with LEDs would be my initial advice, because you still need a ground. They need to be able to sense the load. I put these diodes in. Before I understood it was the relay, I was trying these. These are American Autowire 500, 529 inline diode kits. This diode is designed to prevent backfeed onto a circuit, and they're directional, as a diode should be. And so I put these on the line that goes into the brake turn on these LEDs. Turns out that wasn't it. So the diodes didn't fix it. I'm going to put them in the circuit anyway, but the diodes didn't fix it. Then I tried this relay. I had these from before. This is a CF15JL02, probably a Chinese clone. It does have a ground, which is labeled E, which I think means earth. You've got a B terminal, which goes to the battery, 12 volt. You got an L terminal, which goes to the load, and then you have E for ground. So you can see I made a little pigtail for ground here. Turns out that ground doesn't go freaking anywhere. It's apparently just dead. Now, I use ChatGPT to help me troubleshoot this, and I have a very long thread with ChatGPT, which was helpful to help me keep my thoughts straight as I was troubleshooting. I then bought this Painless Performance part number 8230. This does have a ground, and it's got the other 2 pins. The X is the positive and the L is for the load. And I thought this would do it because it's a painless part and it's made for LEDs, and I thought this is going to work great. I put this one in. This has a very satisfying audible click to it when the turn signal's on, but my problem still persisted, and I still had just solid lights every time I tried to turn on the turn signal. So, yet another failure. Finally, I found this switch from United Pacific. I found this on Amazon. It's part number 9650. 90650. This is a heavy duty grounded LED flasher. I put that in and it worked. So let's go through it and I'll show you why it worked. Now keep in mind, my relay board is not in this circuit, and I'm frankly afraid to try to introduce relays now. So right now the truck is driving down the road, brakes are not on. Brakes come on just as expected. That's great. Brakes go off. I'm driving down the road. I'm going to signal to turn. You hear the click? It's got a nice click to it. Turn signals work just as intended without brakes. With the brake on, yes, they work great. So I've got a flash in the front, I've got a flash in the back, and I've got a brake light on. This is wonderful. This is how it's supposed to work. Now, let's turn the turn signal off. Let's turn the running lights on. Driving down the road, I got my halos on front. I got running lights on my taillights in the back. People can see me. Now I'm gonna turn. Now normally, this is where I would have problems. When I would turn on the turn signal, just the side for the turn signal would freeze, okay? But watch, look at that. Works just like it's supposed to. Look at the halo switching colors. Isn't that cool? Dang it. Horns work too, which is awesome.
Okay, try not to get too crowded on here, but I will have a little positive terminal block here that will be constant 12 volt power. This relay will go to that because this will be the one powering the hazards. The brake light switch will also connect here and then the horn. So I need to make a little like 2-pole threaded insert kind of thing here. All right, I made some room here. I'm gonna use this open space to lay out all the headlights and taillights, and I'm gonna build the wiring harnesses. I'm gonna put excess length on each segment. Okay, those will be combined together. Horns will be independent. That light and that light will tie into this. This one will go to the firewall. And then this will tie into that one. And this will go all the way up to the firewall. So headlights, running lights, blinkers, horns, brakes, of course blinkers, and then that white wire in there is the reverse light, which I still need to figure out how to hook up. So yeah, I think I'm going to end this video here because this is taking forever, and it's freaking freezing outside right now. We got snow coming down. I'm not going to be crawling around under the truck anytime soon, so that'll be a separate video when I finally put all this in. To recap, or to preview, I've recreated an entire wiring kit from scratch, including a fully customized dash made from scratch for a 1980 Chevrolet C10 pickup.